We're talking about lesson 89 today. These are value problems. Value problems, another way to think about these is to treat them a lot like a coin problem, right? This is basically just a coin problem, but instead of dealing with nickels, quarters, dimes, pennies, etc., we're talking about anything that could have value. Okay, so the first question that we're looking at here is one of the practice problems that they give us as an example. So airline fares for flights from Tifton to Adele are $30 for first class and $25 for tourist class. If a flight had 52 passengers who paid a total of $1,360, how many first class passengers were on the trip? Okay, so what we want to do with this is we just want to create a system of equations, right? Whenever we solve our coin problems, we do it. So obviously, when we do value problems, any problem that deals with value, we're going to set up a system of equations. Okay, so let's go ahead and label what our variables are going to look like. Okay, so I'm going to let flights from Tifton. I'm going to let flights from Tifton here, right? We're going to let this, we're not doing flights from Tifton. We're talking about first class and tourist class. So we're going to let first class, right? We're going to label this as F for first class. And then we'll let tourist class, we're going to let this be T. Okay, so these are our two variables. We've got T and F. So I'm gonna set up just a total number of tickets equation. Okay, we've just got a number of tickets equations, right? So we've got 52 passengers. 52 passengers. And I know that on this flight, we've got first class and tourist class, right? So the number of first class plus the number of tourist class tickets add up to the total of 52 passengers that were on this flight. Now, we also know that they paid a total of and let's go with blue here. They paid a total of $1,360, right? This is where we're talking about the value of each ticket, right? It looks like first class tickets had a value of 30, whereas our tourist class tickets had a value of 25. So just like that, we now have a system of equations that's been set up for us. Maybe what I would recommend doing with this is, since we've already got F and T for our two equations, is to go ahead and treat this like a elimination problem, right? So I could multiply the first equation here. I'm going to multiply this first equation. I'm going to multiply it by negative 30. Multiply this by negative 30. And I do that so that I can cancel out this F variable, right? So when I multiply that by negative 30, what I get is negative 1,560 is equal to negative 30F minus 30T, right? So I've eliminated this, right? I've rewritten that as a multiplication or a product of by negative 30. All right, so once we do that, all we got to do is add straight down, right? I'm going to combine and eliminate whatever I can. Well, our F variable ends up canceling, and we're left with negative 5t on the right. Negative 30t, positive 25t, those cancel down to negative 5t. And then over here on the left, I've got negative 1,560 plus 1,360, which gives me negative 200. So I've got negative 200 is equal to negative 5t. Well, if I want to solve for the number of tourist tickets, I just need to divide both sides by negative 5. And I get t, the number of tourist tickets. Well, that's equal to 40. If I know how many tourist tickets there are, then it's very easy to figure out how many first class tickets there are, right? Because I know that the number of first class plus the number of tourists is equal to 52, right? Well, if T is 40, then I've got F plus 40 is equal to 52. Therefore, the number of first class tickets that I have is equal to 12. So what I've got written out for us now is the practice problem A. Okay, practice problem A. Tickets for good seats cost $8 and tickets for other seats cost $3. If 18 tickets were sold for a total of $119, how many tickets for good seats were sold? Okay, so again, we need a system of equations. But to do this first, we should probably go through and label what we want our variables to be. Okay, so let's go good seats. Let's let that be G. And other seats, let's make that something like S or something, because O looks so much like a 0, right? So I'm going to make let's make other seats. Let's make it T. Let's make it T for other seats. Right. Okay, so if 18 tickets were sold for a total of $119, okay, so I know right off the bat that I've got a total of 18 tickets, right? What equals 18? Well, the number of good seats plus the number of other seats. Good seats plus other seats gives me my total number of seats. Now, my value of these is $119. Well, whenever I'm dealing with value, when I'm looking at the value, I've got to throw value onto my variable, right? So good seats have a value of 8. And my other seats have a value of 3. Okay, so it looks like I've got G and T, G and T. Let's go ahead and use elimination. Let's use elimination to solve this problem. Okay, so what I think we want to do is probably multiply this guy right here by -3. If I multiply that by -3, what I end up with is the following. I get -54 is equal to -3G minus 3T, right? And I'm multiplying this by -3 so that my T variables here cancel. What I'm left with is 5G is equal to 119 minus 54, which is 65. Right? And if I want to solve for G, I just divide both sides by 5, and I get G, the number of good seats, is, well, that's just equal to 13. Well, if the number of good seats is equal to 13, then how many other seats do I have? Well, I can just take 13 and subtract that from 18, and I get 5 other seats, right? 5 other seats. So for this, we're treating it just like a coin problem, right? We've set up our system of equations, we've solved for a variable using elimination, and then we substituted that value we got back in to solve for our other variable. Okay, so I've got one more for us to look at. It's practice B. And it reads, at a basketball game, adult tickets sold for $5 and children's tickets sold for $2. Okay, right off the bat, I'm thinking, okay, I've got $2, $5. Those are my values. I've got adult tickets. I've got children's tickets. Those are my variables. So I've got 175 tickets were sold total, right? For a total of $686. How many of each type were sold? Well, let's go ahead and create our system of equations, right? Our system of equations. I've got a total of 175 tickets. And I know that my adult tickets, let's let that be A, and my children's tickets, let that be C. The number of adult tickets plus the number of children's tickets add together to give me 175 tickets. Fantastic, right? So this is just our count, right? If you guys remember when we talked about coin problems, we said, well, this is just our count. How many of each do we have? Now, for value, we've got $686. $686. Well, when I'm talking about value, I have to add value to my variable. So that's $5 for an adult ticket and $2 for a children's ticket. Okay? We have to solve either using substitution or elimination, but I recommend when you've got our variables already on the same side, let's use elimination. It just makes it that much easier. Okay, so here we go. Let's multiply this top one here by -2. We're going to multiply by -2. What that gives us is -350 is equal to -2a minus 2c. Right? We have canceled out this top one and gotten our new equation. Now, this is the same equation as that top one, right? And that's just because what you can multiply both sides of an equation by the same value, and it does not change the value of your equation. It just makes it look a little different. That is our multiplicative property of equality. So now we just get to add straight down. We see that these guys right here, they cancel, right? This cancels out. I'm left with 3a is equal to, well, 686 minus 350. That just gives us a solid 336. Divide both sides by 3 to solve for our variable a. And we get a equals 336 divided by 3, which is, in fact, 112. There were 112 adults at this basketball game. So how many children were there? Well, we know that 175 is equal to the number of adults, right? This is A, number of adults plus the number of children. So we just can take 175 and subtract 112 from it to find that the number of children that were at the game is 63. Now, if you guys have any questions about this, don't hesitate to reach out. Mrs. Carpenter and I are happy to help you guys. Stay safe out there.